wonderful to get the chance to. This is one thing that I really enjoy about now being able to do all this stuff remotely. I know that sometimes it feels a bit sad that we're not in the same place, but given the difficulties of trying to travel into Asia, scheduling and logistics, and I don't know what kind of visa requirements there are, it's really nice to be able to have the opportunity to speak to more audiences around the world, even if we can't be in the same place. But I think it'll go well anyway. So if you have another device available to you, then go to menti.com, use that code. There's going to be a bit of interaction here. So I would be pleased if at least a few of you would join. And after the talk, we'll hang out. I'll answer some questions. And yeah, I think I've probably now given you about 30 seconds to be able to grab your phone and start furiously typing on your browser. So perhaps that will be enough time for some of you to be involved in the presentation as we go. So my name's JB Rainsberger. Most people ask me how they should call me. So you can call me JB, you can call me Joe, you can call me J Brains. I'm happy with all of them. Here's how you can find me. And especially, I'd like to draw your attention to the last link. At any time, if you'd like to ask me a question, please just visit ask.jbrains.ca. I can't guarantee the speed of my response, but it's important to understand that freelance workers answer your questions as a way of developing their marketing. It gives me ideas for writing articles. It gives me ideas for training courses. And I like to be able to help people when I can. So please, if you have a question, even if you think it's a stupid question, even if you think it's an easy question, or even if you think it's a very hard question, ask me anyway. The worst that will happen is that I will take a very long time to answer, but I'll answer with a 3,000-word article. And I'd be able to share that article with the world. I can show the world how smart I am, and somebody will hire me. So when you ask people questions, you are feeding their family. So please do not hold back. All right. So today's topic is unlocking the awesome power of refactoring, which is one of those nice, very flashy marketing sounding titles. And I think that it's true. I think that a lot of people, a lot of programmers have difficulty really making refactoring a central part of their work in a way that generates real results. They have this idea in their mind that refactoring will be helpful. They have this idea in their mind that evolutionary design could help them in a variety of ways, but they don't really feel comfortable doing it in their day job where they feel real-time pressure to do what they think of as real work. And I think that now that we've been working remotely, many of us for close to a year, I think by now we have adopted this maybe not as the way we will work forever, but as an alternative normal. And that means that maybe there's an opportunity for you to make some experiments with the way that you work. If you haven't already been doing this, then maybe now after 11 months, you can decide that you feel confident enough that you have adjusted to this new, this alternative way of working and feel more safe doing more experimenting. And remote work especially means perhaps less of a feeling that someone is looking over your shoulder and that you don't have to justify every step of what you do to a project manager, a technical lead, a personnel manager who is micromanaging your time. Now, some of you, I can imagine, are dealing with some fairly dysfunctional micromanaging kinds of environments. And I feel very bad for the ones of you who are. And I don't want to seem insensitive. But for most people, my guess is people are not watching you quite as closely, and you have more of an opportunity to experiment and to try things. And so I encourage you to use this as an opportunity to practice deliberately. Maybe you've never had an occasion in your career to practice deliberately before. we in the software community have this strange notion that we should always be performing and that we should never be rehearsing. I mean, people who are in the theater, in film, in radio, podcasts, you would never run a wedding without having a rehearsal. So I don't know why it is that software people believe that we're the ones who can always perform and never rehearse. Think about football players, right? Football teams practice and then they play the match on the weekend. Even in baseball, where we play every single day, they play 162 games in 190 days. They're performing every day, but they also spend 3 hours before the game practicing, doing drills. Why don't we? I've been wondering about this for 20 years, and this is an area where I think I've identified some systems and some tricks that can help us incorporate this kind of deliberate practice into our work. And if by chance you've been interested in this topic, then perhaps you've read books like The Talent Code, Talent is Overrated, that talk about how we form myelin in our bodies that helps us develop skill, that actually literally makes the electrical pulses that we need to cause us to do the right thing more easily, that they travel through the body more easily with less resistance. And that's part of what makes the things that we do feel easier. And the number one reason I think why people don't benefit from refactoring and from evolutionary design is that they don't reach the point where it feels easy. And that's really the central point that I want to make today. So, quiz time. Why don't you refactor more? So I'm hoping that the quiz is showing up on your devices. I'll give you a few moments to think about why it is that you don't refactor more in your day job. And with any luck, some messages will pop up. And I'll try talking for about 30 seconds to see if that happens. I know that some of the things that I've noticed are that, because refactoring feels difficult, I think I already do, because refactoring feels difficult, people worry about taking the time to do it, and they're not willing to take the time to do it, so they never practice it. And for the ones who want to practice it, they feel like they don't have the permission or the opportunity to practice that on their real projects in their day jobs. And so as a result, if they don't have the energy and the time to have a hobby project on the weekends or in the evenings, some of us want to actually be with our families and that kind of thing. They never get the chance. And I think that's a real shame. So let's see some of the things that we got. We've got lack of tests. Maybe the rest of the team doesn't feel comfortable with the refactoring that I'm trying to do, so it's hard for me to impose what I want on them. It's hard to know whether the result of refactoring is actually better. We don't really have a good way of justifying to the rest of the group that our suggestions are better. People are accustomed to code review, and a code review for refactoring can be kind of difficult. Not enough tests, so I don't feel confident actually changing the code. So yeah, and focus on features is another thing, of course. The classic argument that we don't have time. So thanks very much for that. I'm sure that will help me come up with some really good ideas for articles. I'm going to move ahead. If you didn't get a chance to type everything in, I apologize. So this is one common pattern that I see where I don't see how to refactor this code. Like I have a picture in my mind of how I think the code could be better, but I have a hard time seeing how to get from here to there. It would be very easy. Well, not very easy. I could see how to throw this code away and rewrite it better, but I have difficulty seeing how to get there in a sequence of refactoring steps, because that's really quite important. When we're refactoring, part of what makes that different from rewriting is that we're rewriting very small pieces one at a time in a sequence that guides us towards the destination in a way where the system is always working and where we can stop at any time if we needed to. Those things are very important, right? This isn't just rewriting things. But because I can't really see how to move there in small steps, if I sit down to try to figure that out today, I worry that I'll go too slowly. And the people around me will see that I'm going slowly. I will feel pressure. Maybe I'm worried about giving a bad impression to a key manager or a key technical lead. And so if I feel always like I'm going to go too slowly, then I really can't afford to try to refactor this code, right? Not today. I have a good idea. I think I know how to do it. It would take 2 days or it would take 4 hours. That feels too slow. I'll try again next time. And if we keep saying I'll try again next time, then I will never be in the situation where I actually take the time to do it now. And that means that I'll never trust myself to be able to refactor any code. I will only feel comfortable throwing it away and rewriting it, throwing it away and rewriting it. And that creates even bigger risk. Now it gets worse. If you start to adopt the attitude that you'll never trust yourself to refactor code, then you run the risk that you will always feel like I will always have to live with the problems in this design. We will never have the opportunity, the occasion, the permission, the capacity to make it better. I'm stuck here. And it's one small step from I'm stuck here to I will never be able to do the kind of good work here that I want to do. I will never get to live up to my potential here. And you might imagine that the next step would be to quit and to work somewhere else. But then what happens if you go from company to company over a period of 5 years and have the same experience over and over again? Eventually, you might reach the point where you start thinking, I will never be able to do good work. Professional software development is fundamentally broken in a way that means that I will never feel good about the work that I'm doing. And that's dangerous territory. I have felt that way. I know many programmers who have felt that way. And it is deeply disturbing for your mental health to start to think this way. And that's the reason why I think this topic is so important. Not because I want to produce better results for my clients, not because I want to feel some kind of, I want to be able to point at my designs and boast about how elegant they are. But if we feel too much like we are stuck, like we can't refactor our way towards better designs, then we run the risk of gradually waking up one morning 5 years later saying, software development is a terrible industry. I wish I had never chosen this as a career, but I'm 37 now and I don't know what else to do. I'm stuck. I'm trapped in this life forever. And that's when feelings of burnout and depression can come up. So what's missing is something psychologists call chunking. So the basic idea here is that as you practice doing something, you chunk. In your brain, what happens is that you take a bunch of things and start to treat them. At the beginning, you have to pay attention to the details of all those things. And then as you practice, eventually you grow, some magic happens in the brain. Those things become familiar and you start to be able to think of them as one thing in your mind. Now, related to refactoring, there might be some very small steps that you have to pay very close attention to in order to do them correctly. I need to copy this code over here. I need to change this name. And it doesn't matter whether you have automated refactoring tools or not. The same thing still has to happen. And so as you practice, the sequence of steps start to form in your mind like a single step. And as that happens, then you find it easier to perform those steps more fluidly and with less conscious effort. The really important thing here is that as you practice refactoring, the steps become so familiar that it feels like your fingers are doing the steps instead of your mind. And that's the point at which you are chunking. This isn't just muscle memory, as in I can repeat this over and over. Something more interesting is happening. You used to think of these 10 steps as 10 separate steps, and now you think of them as one thing that just happens to take 45 seconds and requires pressing 18 keys in a certain sequence. And as you perform these steps, they become more fluid, you do them with less effort, and you can chunk at every level. So you can chunk starting at the individual keys that you press, and then at the level of micro steps. I'm going to rename this thing, and then I'm going to move this function from here to there. Or at the level of moves, such as, I noticed that we have the same implementation detail in 4 places. I'm going to hide them behind an interface, and then I can put them into one place. Or even at the level of strategies, something more like, I'm going to replace collaborators with subscribers, or this publish subscribe model isn't working. I'm going to go back to collaborators. Chunking arises through repetition. And so when you practice something, when you do it repeatedly, it starts to feel easier. And specifically, it starts to feel easier in the way that you use less conscious energy to do those steps. You can do them before you start thinking about them. And as you do that, then chunking happens. So as I said, if you repeat something often enough, it becomes autonomic. That word is slightly different from automatic. Autonomic means that essentially you can do it without thinking about it consciously. The back of your mind is guiding you. The front of your mind is free to think about other things. And that's really the key, that once you start doing things autonomically, then your mind is free to think at a higher level of abstraction. And if you think you haven't experienced this before, you have, because you're doing it right now. Your breathing is autonomic. Now, if you, like me, practice sitting meditation is the act of putting conscious thought into breathing. But most of the time, we breathe autonomically. We walk autonomically. For the people who find it easy to do, picking up a piece of food using some kind of utensil and putting it to your mouth to eat is something that you do autonomically. If you go back far enough in your past, you had to practice those things. You could not do them autonomically. You had to do it with conscious effort. But with enough repetition, because we eat every day, we walk every day, we breathe every day. Well, not everyone walks, but for those of us who walk, we walk every day. Gradually, you didn't need to think about that consciously any longer. And this doesn't just reduce the energy that you need in order to do those things. It allows your mind to think at a higher level of abstraction about other things. So instead of focusing on walking, you can now walk anywhere you want, and you can focus your energy on looking for cars that are going to run you over, making sure that you're stepping on the right part of the sidewalk, making sure that you're walking in the correct direction. These are all things now that you can do. You can think of going somewhere as a single step instead of thinking about, I want to go in that direction, so I'm going to face my feet that way and then go left foot, right foot, right foot, and so on. And one of the problems that many programmers have is that when they try to do refactoring, they are still at the level of left foot, right foot, left foot, right foot. Their mind is not free enough for them to think about the intention behind their refactoring. What is the strategy? Where do I expect the design to go? Evaluating whether design is really improving or merely changing. And so repetition leads to ease, leads to chunking. And you can just keep doing this over and over and over and over again until you know everything, until you master the technique. So I gave a few examples. What do you do easily now that used to be difficult? Maybe something a little bit more recent than walking or eating or breathing. But what are some other things that maybe that 2 or 3 years ago, you had to put a lot of conscious effort in, but now you do autonomically? One of the big ones that, again, we're still bad at is typing. So let me be clear. Typing is not the bottleneck. However, if you can type at 80 words per minute, and if you can type effortlessly, then you can free your mind up to think about what you are typing and don't worry about how to make your fingers put those characters into the keyboard. And there are a lot of programmers that I work with where we sit and talk for 10 minutes about what's our strategy, what are we going to do. We sit there with our index cards and we make lists about what are the micro steps that we're going to go through. And then when it comes time for them to type these ideas into the keyboard, they go really slowly. And it doesn't just slow us down. What it does is they have to focus so much on typing that they forget where they're going. And so one of the things that we do when we pair together is I actually take over the role of being their short-term memory so that they can focus on typing the next line of code, typing the next function, typing the next test. They are a little bit tired after they finally have written, 30 or 40 characters into the text editor. And then they look at me and I remind them what the next step is. If they reached the point where typing became autonomic, then they would be able to think more about what is the next thing I need to do. I'm going to write this test, then I'm going to write that test. I'm going to write this assertion first and then work my way backwards. So even if typing is not the bottleneck in what we do, typing slowly is an obstacle. It is something that's relatively easy for you to practice. And it's something that even you can justify practice during work time. So you can see a bunch of ideas out there of things that used to be difficult and now are easy. Now think about when you put things on that list, don't just think about, public speaking is easier or mob programming is easier. Think about what are the things that you can think about now that used to be difficult because you had to focus so hard on the steps of doing those things. Think about now, what is it that your mind has been freed up to think about because you're not focusing on the details of how to take notes or of how to stop using the mouse, any of those kinds of things. So if you've read Daniel Kahneman's Thinking Fast and Slow, then you'll recognize this metaphor. If you haven't, let me give you the very short version. System 1 is the back part of your brain that's always on, is super fast, remembers everything. System 2 is the front part of your brain. That's the short-term memory where you can remember between 5 and 9 things. And your conscious choices are made up here, and your unconscious choices are made back here. And the only reason that we are not all superhuman machines is that System 1 doesn't know how to send reliable messages to System 2. You've experienced this when you're in the shower and suddenly you go, oh shit, now I know what to do. Or when you wake up at 3:30 in the morning and you finally have a solution to a problem. That's System 1 accidentally getting a message to System 2. I like to think of it like System 1 back here is screaming and screaming and screaming and trying to help you, and System 2 doesn't know how to hear. And every so often they make a connection, right? There's that saying that all communication happens by accident. That's what's happening between System 1 and System 2. When we chunk, we take something that used to happen in System 2 and we give it to System 1. And when you give it to System 1 takes care of it forever. And now System 2 can think about other things. So when you're refactoring, what does chunking look like? So I have come up with this sort of 4 groupings of ideas, 4 categories, levels, I think. You can think of it as chunking goes from the top towards the bottom. And so there are these nano steps, micro steps, moves, and strategies. Thanks, by the way, to G-Paw Hill for encouraging me to call these things moves. So you can see sort of, if you look at that list, you can have an idea of what are the things that for you seem easy and what are the things that for you require conscious thought, and you can get an idea of where you are. And as you practice, as you chunk, the things at the top of the list get easier and the things at the bottom of the list become easier to think about. You are able to think more directly in terms of moves and strategies when the micro steps and the nano steps become autonomic. This is not a maturity model. This is not, you don't master all the nano steps and then master all the micro steps and then master all the moves. You sort of slowly move from the top to the bottom in a variety of ways. And there are some moves which might feel comfortable today and some nano steps that you still have to learn. And when somebody puts you in an unfamiliar environment, like if somebody asks me to write code with Eclipse, suddenly I slow down because I have to relearn some of the nano steps. I like to flip back and forth between Vim and Cocoon. Cocoon is like, what would Vim be if it was designed in the 21st century? And if I am forced to use, like even if I just do sudo and suddenly I don't have access to Cocoon anymore and I have to use Vim, there's a period of about 10 minutes where I have to retrain myself to remember which nano steps. How do I delete a character? I have to type D instead of X or X instead of D. Or how do I move to the beginning and the end of the line? I don't use $ and 0. I use GL and GH. So this is an area where the nano steps maybe I sometimes have to reload some old memories, or I need to learn those nano steps from scratch. Even though I've mastered many refactoring strategies, if you ask me to do editing in Notepad, I'm going to have to learn some nano steps. So let me see if I can show you an example. So here I have some code, and yes, I now see that it's on the screen. Here is a way that you can practice. what you can do is pick a single refactoring. In this case, I'm going to use the refactoring where we replace a single argument with a collection. So here I have a function that takes a single string as an argument, and I'm going to replace it with a collection of strings. So let me be very clear to you about this. I am refactoring in the sense that I'm changing the code. I'm not refactoring in the sense of improving the design. My goal in this kind of practice is not to improve the design. My goal is simply to have a place to practice the steps so that they become more autonomic. And so I pick any code at random. I don't care where it is, just as long as there's something that I can refactor. And all I'm going to do is practice the steps. So any of you out there who have read Martin Fowler's Refactoring book know that, at least in the first edition, the first 1/3 of the book was the explanation of how to do refactoring, why it's important, blah, blah, blah. And the back 2/3 of the book was a catalog of refactorings. Here are some code smells. Here are some refactorings that you can apply to try to improve them. Here's a step-by-step explanation of how to do the refactoring, even at the level of copy this code over here, compile, run the tests. Copy this code over here, compile, run the tests. Nanosteps. So what we do is we use this as an opportunity perhaps to practice the nanosteps. Now I'm going to go a bit slowly because I want to be able to talk as I go. This entire refactoring is the kind of thing that probably by now I can do in between 40 and 80 seconds. But it might take a few minutes for me to do here so that I can talk about it as I'm going. So my goal is to replace barcode with barcodes. I'm going to use the Kent-Beck strategy, add the new thing, change the clients, remove the old thing, because that's safer. So here's a move or a micro-step level idea that I'm going to use. And now the question becomes, how can I use IDEA to help me do this? Because IDEA has some automated refactorings. Now I'm going to do this a little bit by hand. I know there's a shorter way to do this using automated refactorings. That's the kind of thing that a lot of programmers get stuck on. Because the, let's say, longer steps never feel comfortable, therefore they never learn how to really do it well with the automated refactorings in IDEA. I know that I can do this by just introducing a parameter object, but let's pretend I didn't know that. So the first thing I'm going to do is I'm going to add an equivalent parameter. So let's see, this is a list of string. Pardon me, I have to now look over on the other monitor, so it's going to look a bit weird. And I'm going to give it this value, which is probably going to be wrong, but might be right some of the time. And let's import Java util list. Let's not make it complicated. And this might break a little bit, but I'm not going to worry because the compiler is going to help me figure out where I need to fix things. So now if first thing I'm going to do is import. And then if I look over here where this is being used, where is it? Is it here? You can see that says list of barcode. What I want to do here is to pass the same value in two different forms. So the first form is a single, what apparently is called command here. And the second one is a list of just the one command. Now, if I had tests, I would run them, but I don't have tests because this is part of my pubmob.com session that I call Evolutionary Design Without Tests. And if that's intriguing to you, go check out pubmob.com and learn more. This is the only place that calls handle barcode. Let me just check that to be sure. Yeah, that's it. So good news. The first micro step is done, or you can think of this as a nano step, right? So the first nano step is pass the same value in the old form and the new form. And of course, the code is not using the new form yet. Oops, I don't know why that happened. I know why that happened. So now we can see that the next step will be, I can now focus inside here and change this code to use the new barcodes and stop using the old barcode. So I can see that I'm using barcode in two places. So I know that the first step is to take advantage of the fact that I know that barcodes always has exactly one item. And because barcodes always has exactly one item, I can just ask for the first one and nothing else needs to change. And that means, by the way, now that I can remove the old parameter. And that's one place where I use the automated refactoring and it just works perfectly. So you can see now that from the outside handle barcode, we can give handle barcode a list of things, but inside we always assume that there's exactly one. And if I had tests, they would all still pass because all my tests have been written with the assumption that there's only ever going to be one thing. All right, well now how do I turn this into, the next step is to turn this into a loop. How do I do that? Well, the first thing I notice is that down here, what I'm trying to do is to print out all the barcodes that are not found. So now this step is a little bit annoying, and I could do this in shorter steps if I wanted to, but what I can do is something like, I think it's collectors joining. And I think I can give it a delimiter. Right. So let me just put this code down here so that it's easier to see. So what I've done is the equivalent of printing a single barcode, but by saying I'm going to take all the barcodes and I'm going to separate them by commas and print them here. This was relatively simple. We could start by doing stream collect with no delimiter. And I think if you know Java, you can probably agree that this is the same thing, that this just takes all the barcodes and sticks them together. So if there's only one barcode, this is the same code. And then say, well, really, it would be nicer if I separated them by, let's say, comma and a space. Okay, so that's the same as what it was before. This is a little bit more complicated. So what's really happening here is that we are asking for a product that matches this barcode. Don't worry about what that means for now. How would we do this with a bunch of barcodes? Well, maybe we should find the first product matching, and like find the product that matches the first matching barcode. So this is going to be a little bit more complicated, but I think we can do it. So let's try this and see how far we get. So this would probably be, I think it's called catalog. No. Where's find product? Actually, maybe it'll tell me. I want the thing that says find product, and I don't remember what that is called. So let me see if I can find it real quick. I forget what we called it in here. There's something called catalog. So this is an example of me forgetting my own domain. Aha, there we go. Now the problem here is that we are returning optional of product instead of optional of product. So I know that I can do that by doing flat map. My typing is not working well today. I don't know why. Must be too early. And if I type this all correctly. All right, you know what? I'm not doing this very well right now, and I don't know why I'm messing up. So I'm going to stop here. I think you get the idea. The next step here would be to find the. Oh, I think I know why. That's okay. I'm just going to put the code back the way it was. See, I'm consciously thinking about presenting to you, and the autonomic stuff is not kicking in right now. It's a perfect example of what it is that I watch a lot of programmers do right now. Of course, after this talk is over, I'm going to be able to do this refactoring in 10 seconds, and because I'm not going to be trying to think about talking about it while I'm doing it. So that just tells me that I didn't rehearse this demo enough, and I probably should have recorded it as video and just played it. Okay, lesson learned for next time. So the idea would then be to change this to find the first product that's not empty and return it, and then the refactoring would be done. So how do I actually use this for practice? What I do is I set a timer for 10 minutes. I practice those steps. And then once those steps are done, I find another part of the code and I practice them again. And then I practice them again. And I practice them again. And my goal is simply to practice it for 10 minutes consecutively. 10 minutes is not that much time. What happens? Well, even inside 10 minutes, the last iteration of doing this refactoring feels a little bit easier than the first one did. And in fact, when I do this with clients, that's what they report. So we'll set a timer for 10 minutes or 15 minutes. We'll pick one refactoring. We'll go over the nano steps. They'll practice it. The very first time that they practice for 10 or 15 minutes, maybe they only do the refactoring 2 or 3 times. But they already noticed that the third time felt easier. So then we take a break, maybe we grab some coffee, we talk about some things, and then we come back, we set the timer for 15 minutes again, and they do it again. My goal is not to see them to go faster. My goal is to see them to go easier, for it to feel easier for them. So even if they don't go any faster, even if they still only do it 3 times, if it feels like less effort for them, then that's really my goal. And by the end of a 2-hour session, they start to notice that some of the nano steps that they learn, they used to think about it at the beginning of the session, and now their fingers do it autonomically at the end. And if they pick up 1 or 2 nano steps or 1 or 2 micro steps in a 2-hour session, that allows them to go more quickly for the rest of their career. The next day when they write code, they notice that they save 4 minutes. And the day after that, they save 5 minutes. And the day after that, they save 6 minutes. And gradually this adds up to real money. Now, chunking does lead to increases in speed, but more importantly, it leads to increases in courage. And this to me is really the awesome power of refactoring, isn't in being able to do it more quickly or more easily, but to do it more confidently. And not because any particular refactoring that you do is so important, but when you refactor more confidently, then you will refactor more, you'll volunteer to refactor more, which means that you will feel more successful as you go, and you will bring more energy to the job. You'll bring more energy to the job, you'll see more hope, more opportunities, and you will actually do it. You will feel less resistance to refactoring. And let me be clear, you'll feel less resistance to changing the design. This is where the real power kicks in. So you can start practicing now. You don't need to spend 2 hours. You could spend 30 minutes at the end of every task. If you do tasks that average 2 or 3 days in length, adding a feature, fixing a defect, whatever. If the units of work that you do are 1, 2, or 3 days long, it's very easy for you to spend 30 minutes after that's done, but before you tell your manager. Shh. When you do this, your manager doesn't notice the difference between you finished in 2 days and you finished in 2 days plus 30 minutes. So you can spend 30 minutes at the end of every task or once a week, pick any nano step that you stumble on, pick any micro step that you stumble on, and just practice it. Grab some code, practice, or grab some code, set the timer, practice. At the end, throw your changes away because you don't need them. Occasionally, you get a good idea for refactoring, you write it down in your inbox, and then you do it later. And again, this is a little bit like sitting meditation. One of the common questions people have when they practice meditation is they wonder if they are doing it correctly. They wonder if they're thinking the right things or not thinking the right things. And one of my early teachers told me, as long as you try again, you're doing it correctly. Well, I think the same is true here. As long as you try again, even if you stumble, even if you have a disastrous session and get nothing done and nothing changes, if you try again at the end of the next task, if you try again next Wednesday, you're doing it correctly. You have Slack. You'd be surprised. There's lots of wasted capacity thinking too long about nanosteps, thinking too long about microsteps. These things could be easier for you. You could do them with less work. You could finish them sooner. You could do them more accurately. If you practice, you will gain that excess capacity back. You don't have to give all that excess capacity to your project. You can give 50% of it to your project and save 50% of it to do more learning. They still benefit, and you can reinvest in your own capacity in a way that will make it easier for you to improve even more over time. So this chunking, repetition leading to chunking, leading to feeling more courage, being more productive in your refactoring, all these things create this virtuous cycle where your skill, your effectiveness grows over time. You have excess capacity, try using it. You'd be surprised how much you have. Practice wherever you notice that you have to pay attention. So if you're working and you notice that you have to concentrate very hard to do some part of that work, to type a special kind of thing, to figure out which keystrokes you're using, to think of a good message to put in your commit comment, there's a special kind of refactoring that you don't do very often. Any of these things, when you notice that you have to work very hard to think about a thing, that becomes a candidate for practicing so that you can chunk. And in refactoring, like I said, that could be remembering the keystrokes in your editor. That could be having a good system for thinking about commit comments. That could be practicing big scale refactorings like collapsing layers, or small level refactorings like safely moving a method from one class to another. Whatever it is that you notice that requires conscious attention, those become the things that you practice during your 30 minutes once a week, your 30 minutes at the end of every task. And by the way, I didn't mention it before, but I want to say it now. If you practice for 30 minutes at the end of every task, and you do this for a month, and nobody is complaining that you're going too slowly, try an hour. And if you do it for an hour each task, and a month later nobody's complaining, try 2 hours. Keep doubling it until somebody starts to get nervous that you are spending too much time not working, even though you are working. And when you notice that it starts to feel uncomfortable, or if somebody starts making a comment, if your manager calls you in for a meeting, a one-on-one meeting to discuss why you're going so slowly, now you know you have reached the limit. Stop there. That's as much as you can afford to invest in this environment on your own development. Keep investing. You'll notice that the benefits will come in. And by the way, as those benefits start to come in, you'll notice that you're delivering work sooner than you used to. Again, you don't have to give all the capacity back to your manager. You don't have to give it back to your project. You can give them 50% and keep 50%. Eventually, you will reach the point that I reached early in my career, where I was delivering value at 3 times, 4 times, 5 times the rate of all the people around me. And I wasn't being paid 3 times or 4 times or 5 times what the people around me were being paid. So I didn't have to work at full capacity during my day job. I could spend 1 hour, 2 hours a day learning things on my own, feeling confident that I would give some of that benefit to the company and keep some of that benefit to myself. And when I say this to people, sometimes they get nervous. They think that I'm cheating. They think that I am misrepresenting. They think that I am doing something unethical or immoral towards my employer. And I strongly disagree with that. And if you would like to have that conversation with me, I'm happy to do that, just not right here. Remember some of the rewards here. The rewards of chunking. Some of them are, I know there are managers listening here, and I'm not worried. If they think that people aren't already doing this, then they do not have enough experience as a manager yet. And if they think that this is contrary to their employment contract, I will have a discussion with your manager if you're worried about that. Ease and confidence are some of the rewards. I want programming to be easy. And maybe a better way to say it is, I want the routine parts of programming to be easy. I want to focus my energy on the hard parts: modeling, understanding the customer, making difficult trade-off decisions at high-level design, the level of architecture, the level of scaling, solving difficult, thorny problems, focusing my energy on figuring out how to make Stanley's crappy library work the way I want it to work. I don't want to waste my energy trying to remember how to use Control F6 to change a method signature, or that I should copy the body of the method over there first, then make the old method call the new method, and then inline the old method, because inlining the old method is something that IDEA can do automatically, and I can't get it wrong. I want those routine parts to be autonomic so that I can focus my energy on the things that they really pay us for: wisdom, judgment, decisiveness, experience. And so that's really one of the rewards, is that the routine parts of programming, of design, of refactoring become easy, which reduces the resistance, which means that I'll do it more. And if I'll do it more, then I'll practice more. And if I'll practice more, then I'll get even better at it. And pretty soon you will be one of the stars. You will be one of the people that others look up to. And if that feeds your ego, go for it. I'm not ashamed to say that it fed my ego, and that's one of the reasons why I wanted to do it when I was 27 years old. I care less now. Not zero, but less. One of the really important consequences is that these rewards don't just improve your effectiveness, but when you find something easier, your brain works harder to remember it. Think about what happened 200,000 years ago. You found food and you ate as much as you possibly could. There was still food left over. When you had all those chemicals running through your body telling you that, yay, I ate food. This is wonderful food. I love this food. I'm so happy that I found food. Your brain worked harder to remember where that food was, so that tomorrow, next week, next month, you could more easily go back and find that food. The reward system in your brain tries harder to remember things if it thinks, if it anticipates that you are making your life easier. And so when you learn to refactor this way, when you chunk, when things start to feel easier, when you notice that you put less conscious effort into the nanosteps and the microsteps, your brain will work harder to remember the next level of abstraction. And that becomes another virtuous cycle. This is where the real power of refactoring comes in. This is what will make it possible for you to make evolutionary design the way you design things. And maybe the most important aspect of that is that when you begin to trust your skill to evolve a design, you stop worrying so much about getting it right the first time. There is no such thing as getting it right the first time. You can just put whatever nonsense is in your head into the text editor, make it pass the test, laugh at how terrible it is, and then start refactoring. And that reduces the resistance between what's in your head and having it working in the computer. That's when you start to really benefit. That's the awesome power of refactoring. That's what makes it so important. And part of the way that works is that as you make the small parts of it easier, your brain tries harder to think about and remember things at a higher level of abstraction, and that just keeps compounding and compounding and compounding. So if you want to unlock the awesome power of refactoring, where do you start? Here are some places where you can start. I would be thrilled if you read some more of my stuff. Stanley was very kind to say some good things about my writing. I still write a fair amount of this stuff. You can see a series called Free Your Mind to Do Great Work, where I talk also about general psychology stuff as it applies to the life of a software professional. And since I still identify as a programmer, even though I'm not writing code for money most days these days, I still identify as a programmer and I think as a programmer. So I try to filter these general psychology ideas through the context of the typical programmer. But you don't have to stop there. You can see topics on that list that have nothing to do with programming. Also, I've launched a new concept called the Refactoring Workout. So if you'd like, please go to refactoringworkout.jbrains.ca. It's not free, but it's fun. It's essentially a chance for you to try some of the stuff that we've talked about, along with discussing some more general concepts about evolutionary design and refactoring in an environment where you have time to practice, space to practice, and have me to help answer some of your questions. And of course, if you or somebody you love needs some test-driven development training, then I have my self-paced course that has now been out in the world for over 7 years at tdd.training, which includes not just how to do the steps of test-first programming, but how to take test-first programming and refactoring and put them together as test-driven development. So, sales pitch is over. Thanks very much for your patience. The last message that I want to leave you with is that unlocking the awesome power of refactoring lies in reaching the point where the concept of refactoring, the idea of refactoring, feels so easy to you. You feel so confident in your ability to figure out how to get from here to there in 37 little steps that you no longer need to get it right in your head before you type it into the computer. You can type into the computer the first thing that might possibly pass a test and then refactor your way to greatness. That is what Ward Cunningham meant. That is what we in the XP community meant 20 years ago when we talked about doing the simplest thing that could possibly work. Return 12. Oh yeah, 12 really means this. Well, 12 really means 4 times 3, and 4 comes from there, and 3 comes from there. And even though it took me 5 nanosteps to do it, because of this chunking, because it's autonomic, I can type all 5 of those nanosteps in the time that it takes some of you to type the final answer once. And that's the real awesome power of refactoring. When you can actually do more work and finish sooner. For the managers out there, that's a koan for you to think about. Thanks very much for your time and attention. I really appreciate it. Let me stop sharing the screen now. And I think now we'll have my smiling face again. Thanks very much for the ones of you who are applauding right now. I do appreciate it. We don't have a lot of time left for this evening. Some of you are probably tired and would like to go to bed soon, but we do have a few minutes. I'd like to answer a couple of questions. I promise you, all the questions that you asked in that presentation, I will have a record of, and I will write an article where I answer every single one of those questions. And some of those questions will probably end up becoming longer articles. So please stay tuned to blog.jbrains.ca and blog.thecodewhisperer.com. Read on, subscribe. Some of us still use RSS, you know. Stanley, if there's any questions you would like to try to ask me, I will commit to answering them briefly.
Sure. So I noticed from your Mentimeter, there are 3 questions.
Okay.
Yeah. So I think the first question.
Since I'm going to answer those, if there are questions in the Zoom chat, maybe let's focus on those.
Okay.
Yeah, and I'll answer the Mentimeter questions for sure later.
Okay.
Thanks.
Zoom chat. Let's see. Yeah.
And if there are no good ideas there, then go back to the Mentimeter questions.
Yeah, there are no questions in the Zoom chat.
None?
Yeah.
Oh, you all went to Mentimeter. Okay, then let's do it. First one, please, go ahead.
I'm not sure if this is a question. It says not comfortable yet.
Not comfortable yet. Okay. So if you're not comfortable yet, that's okay. The good news is if you have some system for becoming more comfortable today, a little bit, that's all you need. So what I provided here today is a system for increasing your comfort level a little bit. And so any system like this has 2 basic ingredients. I figure out how much investment can I make today, and then I decide how to do it. And that's where this 30 minutes idea comes from. Many people feel like they do not have the right, they do not have the permission, they do not have the opportunity, they do not have the capacity to practice. I think you are wrong. For maybe one of you in this group, there are how many here? 67, so subtract my tablet over here, 66. Out of the 66, now 65 people, one of you maybe is working in an environment where they watch you so carefully and so closely that you cannot spend any time practicing. Okay, I feel bad for you. I want to help you. That's a different talk. For the rest of you, for sure you can spend 30 minutes. And even if you cannot spend 30, you can spend 15. Even just to think about what might be missing, what do I need to work on? And so start there. And your goal is just to be a little bit more comfortable today than yesterday. And we've probably all seen this before. If you make a 1% improvement, but you do it every day for 365 days, you can do the arithmetic. Go to your calculator, type 1.01 to the power 365 and subtract 1. This is how much improvement you make in 1 year. Start slowly. Compounding is wonderful. It's not just wonderful for your money, it's also wonderful for your skill. So don't worry if you're not comfortable yet. You will get there, I promise you. Repetition is the beginning. Okay, that wasn't so brief, but it's important to me, so I wanted to answer a bit more.
Right, we have 5 more questions.
I will try to make 30 seconds answers for each one. Let's go.
Okay, no test to cover the code.
Okay, I have a course called Surviving Legacy Code where we talk in full detail about how to do that. And I am doing this as a live course in the middle of April through techtalk.at. There's also a self-study course. The short version is you probably think that you need to add tests. Yes, you do, but that's not your only possible move. There are more options out there. So Surviving Legacy Code, go find it on DuckDuckGo, and because friends don't let friends use Google. So, okay.
Next question. I think it's about a coding demo. It says, so you add a second parameter rather than a parallel method.
Yes, if you want to do parallel method, no problem. Same technique. The only difference is now you will make the old method call the new one, or you'll make the new one call the old one. So you can think of the move like this. add a second method that takes a list. Then you say, aha, I get the list. I take the first one. I call the old method. And then you change the clients. And then you switch. Now the old one calls the new one and says, I always give you a list of one. The new method iterates over the collection. And then when you're done, you decide, do I inline the old one because nobody should use it? Or do I keep it as a convenience if you have one item? It's exactly the same, except for the nano steps. At the level of a move, it's the same. And even at the level of a micro step, it's kind of the same.
Next question. How do I train myself to identify ways to refactor? I face the problem of not being able to see where to start.
Okay, so this is where, okay, 3 parts to the answer, I think. 1, some of your design ideas are intuition, meaning you just think of them. This is when system 1 is telling system 2 something. You develop intuition when you practice something, and then you begin to have the idea before you have the conscious thought to have the idea. You repeat. If you refactor and practice refactoring in real work, you will develop this intuition over time. So I have an article called Becoming an Accomplished Designer. Talks more about that. Second part. You can always, in fact, this is the only other part. Kent Beck wrote about his elements of simple design 25 years ago, maybe more. I still use those today. So I wrote an article called Putting an Age-Old Battle to Rest. You can look for the phrase simple design dynamo, and that will show you how to go from Kent Beck's elements of simple design to this way of thinking that will very quickly develop your, we call it design sense, or your design eye, where you start to think about which things should I refactor now. It is always safe. If you don't know what to do, it's always safe to try removing duplication or to try to improve the name of something. And if you do this 10 times in 15 minutes, suddenly you will go, aha, now I know how this code wants to be organized. Now I will do it. And every time you do that, you see one more example that builds up this intuition in the back of your mind. So just start by trying to remove duplication and improving names. And if you don't know, add a test.
Next question, awesome speech. May I know what inspired you on the refactoring?
I didn't hear that last part. Try again.
It says, may I know what inspired you on the refactoring?
So I was a terrible programmer. I would write 5 lines of code and make 2 mistakes. And I felt like I wanted to be better. I had this abstract idea in my mind. I want to be better at this when I was 24, 25 years old. I thought I was very good. And then I tried to do work for my employer, and I had lots of bugs, and I had very interesting conversations with testers. And they said, your work is not good. And I had to agree. And I would reach this point where I would work for 3 months, and then it would be impossible to fix the code anymore. So I would throw it away and start again. And so I had this obvious thought, I'm doing something wrong. So then I started to do some web searches. And the first thing I found was JUnit. And the second thing I found was extreme programming. And the third thing I found was the Refactoring Book. And when I read the Refactoring Book, I just went, wow, this is it. I love this idea that I can make the solution grow over time, and I don't need to throw it away and start again. And that's really where it started. And I did it for the first time on a real project where I did rework. Work that previously required 3 months of effort, I did it again in 3 weeks by doing test-first programming with a little bit of refactoring. I started to see the real benefit of writing tests, but I also started to see the benefit of doing something simple and then generalizing a little, and then generalizing a little more, and then generalizing a little more. And once I saw how effective that could be for myself, I was purely selfish, but in the best possible way. I knew this would make me more effective. I knew that would benefit my employer, and I knew it would benefit me. So I made the decision to start practicing. And I was lucky that I became a professional programmer in 1997, and the refactoring book was only 2 years later. So it was a perfect timing for me, and that was purely luck. If I became a professional programmer in 1985, maybe it would have been different.
There are still quite a few more questions. JB, are you okay to
I can
go
stay
for
if
another?
people, yeah, I am
Okay.
happy to stay.
All right, let's go for another 7 minutes.
Okay.
Next question is, how do you apply these skills in a mock programming session so it does not just become programming theater?
Yeah, I think that when we're doing ensemble programming, anytime that we're programming with other people, we are discovering new nanosteps, and we're discovering how other people have chunked. So I see how Kiro did something when he was typing, and I say, wow, that was interesting. Tell me about that. And maybe I say to myself, I like his technique better than mine. I'm going to try it when I type next. That's part of the benefit of pair programming, of ensemble programming. Anytime we program with other people, we are discovering how other people have chunked, and those tricks become things that we learn. So I agree that we might have the problem that it becomes a little bit too much performing. I'm going to try to do everything with perfect nanosteps. That's not the goal. Unless we all agree that that's what we're going to practice today. For the next hour, we're going to practice making nanosteps autonomic. And so if I start typing and Chris says, no, 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 I have a better sequence of steps, let's try it. For 1 hour, we have agreed at a group that this will be the way we work. And then we say, okay, that hour of practice is over. Now we go back to trying to finish this feature as quickly as we can. We go back to using the techniques that we are familiar with. And maybe there is one thing that Chris taught me, one thing that I noticed Alex do that I do a little bit differently now. So that way, I think that in many cases, if we simply agree with everyone that now we are practicing, now we are not practicing, now we are practicing, now we are performing, a lot of these questions go away. And if Alex doesn't want to practice, then we say, okay, fine, Alex, at 11 o'clock, we start performing again. You go away and come back. We're happy, no problem.
Okay, next question. In the refactor step of TDD, how do you reason about how much to refactor?
So I use a self-regulating system. So a self-regulating system is two things. There is the habit that you do, and there is a rule that you follow. So the habit that you do is probably refactoring less. You get excited about making the feature work. You get excited about fixing the defect. So you blah, 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 and you try to write more code. And it's okay if the code is a little bit messy, but because you are excited to make something work. So your habit is to refactor less. The rule goes against your habit. So the rule might be, for example, if I have to make more than 3 changes in order to make the next test pass, probably this means that I didn't refactor enough in a previous step. Or if it takes me more than 2 minutes to make the next test pass, or something like this. There's some rule which tells me when, it gives me some signal that I didn't refactor enough. It gives me some signal that if I had refactored more previously, this would be easier now. It could even be just as simple as this step feels hard and it should feel easy. I have this tight feeling in my chest. Okay, so what happens when you have this tight feeling in your chest, when you have this feeling of nervousness? You follow the rule that says, I need to refactor more. Now we have a self-regulating system. When you feel the tightness in your chest, you start to refactor more. As you refactor more, the tightness in your chest goes away. As you feel better, your habit takes over again, and you start to make bigger steps and you refactor less. And then you feel the tightness again in your chest and you start to refactor more. And what happens over time is that this oscillation between too much and too little starts to stabilize. And as it stabilizes, that is your style. That is your preference. That is your temperament. That is how you like to work. And now the question becomes, If my habit is to be way up here, being very careful and refactoring a lot more often, and David's is to be down here and to take bigger steps and to refactor less often, we might have some difficulty working together. But if we work together, gradually, either our styles will converge or our styles will diverge. If our styles diverge, that means we cannot work on the same team now. That's okay. David works on that team, I work on this team, and 3 months again, we try. 3 months later, we try again. But that's all you need. You need a habit and a rule that tells you when this habit is not okay. So if your habit is to refactor less and to wait until later and then do a bigger refactoring less often, you need a way, a rule, something, a signal that allows you to say, this is becoming a problem now. And then you follow the rule that says, when I see this signal, I refactor more. When the signal goes away, I will naturally refactor less. And then the signal comes back and I refactor more. And then that's it. That's all you need. That self-regulating system will cause you to stabilize. And then as your skill increases, maybe where you stabilize changes over time. That's enough to get started.
Nice. Next question, TDD seems at odds with open-close principle. How do you modify existing code and comply with open-close principle?
Yes. No, it doesn't. I can understand why it seems that way. What happens is that as we refactor more, and actually, especially as we add more tests, there is one piece missing. Most programmers do not pay enough attention to the details in their tests, which are not related to the thing that they are checking. So every test has one thing we are checking, right? There's something we are making assertions about. So I'm going to call this one a relevant detail. A relevant detail. This detail is relevant. Every other detail in my test is irrelevant, not relevant. Most programmers do not remove the irrelevant details from their tests. If you practice to remove irrelevant details from your tests will become more focused, and the modules that you will build will become smaller, and they will become stable sooner. And when they become stable sooner, I mean stable in the sense that they don't change. They always work. I don't mean that kind of stable. I mean really stable. As you do this practice, the modules become more stable, which means they change less often. And they change less often is the same as becoming more closed. And then when you add code or when you add features, more often you are adding code instead of changing existing code. And you get, as far as I know, if you pay attention to this point, the open-closed principle happens for free. You get it by accident. But most programmers don't think about this. They just copy and paste the test, and they have all this setup code, and they just say, oh, this is just, we have to live with it. If you work hard to fix that problem, then you get the open-closed principle as a side effect, as a consequence. In fact, it's a different way to have the open-closed principle. You can either do it directly, or you can get the open-closed principle by ruthlessly, relentlessly, carefully removing irrelevant details from your tests. And I've written an article years ago called, what is it? How what your tests don't know will hurt you, something like that. And that talks about this idea. It's something that I write about. I didn't write about very well recently, but it's a central part of my TDD training course. So if you want that and you want to pay for some training, then go to tdd.training, and this is one of the key points of the course.
Right, I think we should wrap up now. And before that, one last comment I want to share from Kiro is that he says that I really would like to see extreme fishbowl sessions happen again. And this let me recall the time that I saw you and Uncle Bob doing that in the Agile conference. Wow, that was amazing.
So it was so much fun watching how you code, and then it made me good motivation. I need a lot of more practice. Thank you very much.
Oh, thank you. And I agree. I would like to do more of these. I am becoming more sophisticated in recording. And I have we are now forced to become audio engineers and television producers now. So I'm extremely bad at it, but one level above unacceptable. And I actually have a discussion about TDD that I need to edit. And when I edit, I will be able to publish it. I was missing it. I had a technical problem. Now I know how to solve it. And I would like to do more of those, to have discussions with maybe 3 other people, so that it's enough discussion, enough different ideas, different viewpoints to be interesting. But you don't have the problem where everyone just says one thing because they only have 2.5 minutes and then the session is over. So I would like to do one of these things, and certainly I will be trying to invite people, and I want to have a nice mixture of the old XP guys like us and the new people who maybe learned test-driven development this year or last year or 3 years ago, so that I can understand more, what are they thinking about, what do they care about. When we learned these things, the context was different. Some of the problems were the same and some of the problems were different. And I worry that, yes, we are wise, but I also worry that maybe some of our ideas are a little bit too old. So this would be a good opportunity, and I'd like to have this mixture. So I hope, Kiro, that you will be available to join me for at least one of those discussions.